And thank you everyone for joining us here in Seattle or the Puget Sound region and beyond. My name is Armando Berdiel. I am the Technical Development Supervisor with Lighting Design Lab. And we are very happy to bring you a special series in the month of June. We're going to have 3 deliveries surrounding heat pumps in multifamily, commercial spaces, and water heating. So today we're going to be delivering a presentation on multifamily heat pumps. It's going to be a great panel today. We have many presenters and panelists, including Duane Jonlin from Seattle Department of Construction and Inspections, Ben Roush from FSI Engineers, Emma Johnson from the Customer Care and Energy Solutions Division of Seattle City Light. And we also have Howard Merson and Sarah Brown from Energy Solutions. So very excited to bring you a great presentation today. Going to be covering a lot of information with code, with availability of heat pump technology in the market, with how we approach code and design, and a little bit about programs and incentives and rebates from Seattle City Light. But before we get started with the official presentation, we wanted to light the proverbial heat pump fire in our butts as to why this is important. And for that, I'm going to introduce Emma Johnson again with Seattle Customer Care and Energy Solutions Department. Take us away, Emma.
Good morning, everyone. So as we get started here, I wanted to provide some cooling food for thought. We have entered a new era in the Puget Sound region where we are seeing 90-degree days in May, and it's a common occurrence. And the value of providing air conditioning for apartment dwellers cannot be understated. It can be incredibly oppressive to be in a hot apartment, and tenants are looking for cooling. So we want to make sure that we provide some resources for those tenants for efficient cooling, because if cooling isn't provided, they will bring their own, either a window shaker or mobile unit, and that could result in the increase of hundreds of kilowatt hours per unit per year. Additionally, installing a heat pump or a variable refrigerant flow system could provide a lot of lifetime energy savings per unit compared to just one of these, inefficient window shakers. And what we're seeing is the market is really moving towards ductless heat pumps, especially for low-rise multifamily units. And this is something that's happening without Seattle City Light intervention. We're only seeing, a handful of multifamily projects coming in our custom program in this last year. But we're here to help. We want to make efficient cooling the norm for multifamily in all sizes of buildings, and excited to talk to you about some options for helping you move towards efficient cooling.
All right. Thank you very much, Emma. And if you've had our webinar before, you'll know the drill, but I'm going to go through this quickly. Everyone's going to note that you are going to be muted. However, you can still engage with us in the chat feature at the bottom right of the GoToWebinar dashboard. You can submit questions and comments. As we see natural stops, if there's a question relevant to a specific slide, we can ask the question live. We can also answer some questions on the chat ourselves. Also, after the webinar, there's going to be a short survey, and part of the survey has a note. If you are an AIA member and have your AIA number and want credits, we are providing learning units, as our Lighting Design Lab is now AIA continuing education provider. So look out for that if that is pertaining to you. And also a recording of the slides will be posted on a recording of this webinar, and the slides PDF will be posted on our website shortly after the webinar itself. And if you have any questions, you can always email us at lightingdesignlab@seattle.gov. Next slide, please. Just wanted to call out, hey, this presentation is brought to you by Lighting Design Lab, Seattle's Department of Construction and Inspection, and the Customer Care and Energy Solutions Division, powered by Seattle City Light. Next slide, please. All right, and I think I'm going to tee off and we're going to get into our presentation. Ben Roush and Duane Jonlin, please take it away.
All right, my camera should be coming on. There you go. I'm Ben Roush, principal at FSI, both a mechanical and a fire protection engineer, and a whole lot of other letters. The biggest one on here, the reason that I'm here today, the reason you should think I know anything at all, is I really do geek out on codes and the incentive structure set up therein. Looking forward to talking about this today. Oh, Duane, you're muted.
Yes, Duane, yeah.
You'll notice that Ben's hairstyle is markedly different in his photo than in his current incarnation here.
I like to call it pandemic hair.
Yeah. Why pay barbers? And I'm the other half of this show today. This is me. I spent most of my career in the private sector, being the technical guy on big complicated projects, and now for closing in on a decade, have been doing the energy code for Seattle. I want to say that this is what we're talking about today. A lot of it looks challenging, and it's all possible. We can handle it. Anybody who's been watching my talks for the last year or so is really familiar with this slide, but these things that I've highlighted in yellow are a big deal. Most places in the country, they're still arguing, are we going to make our code more stringent or not? Here we have state law and city legislation saying, no, we're going there, and here's the schedule, and we have to do it the best way we can. So the argument here in Seattle and in Washington State is, what's the smartest and most effective way to get there, and to get there with speed? So we're going to run through. This is my cover slide. I'm calling it Snow White and the Seven Dwarfs because there's one at the top that a lot of you are going to like, and then that doesn't involve a heat pump, and then 7 heat pump varieties. And I'm as an architect always dependent on my comrade Mr. Roush there, but you can see that first one is highlighted in red, and that's where we'll start. That we carved out this exception in the code saying, okay, if you're 750 watts per room or less, you can do electric resistance. And the thought being, at some point, it gets to be a small enough heating load that it doesn't make a lot of sense to install a heat pump system. As you heard from the intro, though, when Emma was speaking, this obviously does not give you the option of cooling, but this is real standard all over the city for affordable housing and for others. We actually started with 500 watts per room, and then some affordable housing provider called up and said, can we make it 600 so that if we're over a garage or something, we can have a little extra allowance for that loss through the floor? And then somebody said, you know, most product types don't go any smaller than 750 watts. So let's do that, and we'll do 1,000 for a corner room. It's obviously cheap, obviously easy. That Cove heater at the top seems to be the more popular version of this these days. It stays out of the way of your furniture and provides some, I guess, some radiant heat. So that is your option if you don't want to put in a heat pump. And somebody from RDH looked at heat loss through the walls. Typical Seattle apartment building with a big slider as its window is coming in below 500 watts. If you're got a larger room on a corner, it's coming in at 1,000 watts for wood frame or 1,200 for high rise. So even there, where you got 1,200 for high rise, it's going to be a lot cheaper to just do high quality glazing. Maybe go to triple glazing and cost you an extra $1,000 or something like that, and your 1,000 watt allowance would cover that. So look carefully at your heat loss stuff, but but if you don't want to do a heat pump, all you have to do is be really careful about how you design your building envelope. So with that, Mr. Roush has something to say about cooling.
This is a little bit of a repeat on the front, but our design temperature, this is Seattle, but our design temperature says 85 degrees. And yes, there are a great many days over 90 at this point, and we don't do a lot of projects without cooling anymore. But at 85 degrees, that's 35 hours a year that you would expect at that 0.4% percentile. I think we're actually higher than that now. And this June 1st, a mere week ago, was a rarity. It was up with 4% of the past historical record for actually hitting into for June 1st over 80 degrees. So we believe you're going to need more cooling in the future. It is worth saying, and I do get this objection, but electric resistance heat, if you add cooling, they're going to use the cooling. And I 100% agree with that. If you cool it, they will use the cooling. And you will still be energy ahead over electric resistance heat, says our energy modeling, because heat pumps are so much more efficient. And if you're a developer on the call, you can charge higher rents. So win-win.
Okay, heat pump system number one, and this is quite popular, a ductless mini split. It requires a one-to-one relationship between apartments and their outdoor units, and so you might have seen roofscapes with rows and rows of these things lined up. That thing under issues where I say refrigerant lines limited to 50 feet. Well, Ben, did I get this right? Was it 190 feet that Mitsubishi is talking about?
Yeah, they do have limits of lift, how much up and down you can go before you get oil separation. But yeah, you can go a long way horizontally, and a good, the last one I worked on, it was 40 or 50 feet up to, and they were okay. They can also reduce those line lengths and get you a little more lift. So that's a talk to your rep on your equipment sort of thing.
Right. So it might be possible then to if you're bringing stuff from up from the ground floor and down from the roof to cover 10 stories or so now with these systems. The other option, as shown in the top sketch there, would be that your outdoor unit is somehow integrated with the outdoor deck design. I've seen a couple of those, and just note that condensate will have to go somewhere, and it's going to probably go into a pump or down a gravity drain. And you'll be interrupting me with commentary as we say up along.
Yeah, so my commentary, and this is true for every system we're going to show you from here, the longer the line length, the less efficiency you get. The tests for these that give you that SEER rating, that HSPF rating, keep going right down the rating wormhole. But they're all tested with a very set, very prescribed line length. So as you go further and further and further and further and further, you make your compressor work harder. Just be aware that you might not get your mileage may vary.
Right, and any of these heat pump systems, see this one we're saying 8 to 10K per apartment. That's in context of I guess market rate all in is probably $300,000 or $350,000 per apartment. So it's increasing costs somewhat. VRF is popular for bigger buildings. By the way, the diagram here doesn't show the fact that the VRF actually feeds to these boxes that each box then can fan out to a large number of different units and provide the asked for heating and cooling to those. But that's a less cluttered roof because I think there's one brand I saw that could take 70 units in interior for each rooftop unit. It costs a lot, but it doesn't take up much space because it's pipes and it's pretty simple. And so that's been going into a lot of our high-rise residential.
Hey, Duane and Ben, I have a quick question here. On a quick average, for a 7-story or taller building, then would they not be able to use rooftop units?
They could, but they might need some in the parking garage. So if they were like slab on grade and no parking garage, that might be true. But a lot of times you can get away with, you know, parking garage feeding up and roof feeding down, and there's ways to get creative about this. It's the same truth on VRF. There's a limited lift, though it is larger. We recently did a high-rise building that lifted 8 stories, and those were like 11 feet floor to floor. They had slightly higher ceilings. You know, so it was a close to 100-foot lift, but it definitely had an efficiency impact, and it also had some early compressor failures that have us a little worried. So that might have been a manufacturer thought they could, and we might not actually be true by the time we're done.
All right, thank you for the note.
Oh, you got to note the refrigerant here. So for the engineers in the crowd, ASHRAE 15 and R410A, there are some really specific rules about the volume of refrigerant you put into a specific, you know, size of room, a specific volume of room, and a maximum you can reach. And that's something to be thinking about pretty hard here. R410A displaces air. It just is how it is. So it can limit your system volume before you need to start figuring out how to have, you know, sensors and controls and some fancier things. So it's and it's something that I don't know that all designers are really taking a hard look at.
The other thing to say about refrigerant with a VRF system is that most of the time when we're talking about refrigerant, it's just cycling around within the equipment itself. And so it's a relatively small volume, short pipes, and all the connections are made in the factory. This is a system that snakes all over the building with hundreds of connections, and you just have to have one of those not properly seated, and you could have a big long-term problem. So here is a situation where you have a very large volume of refrigerant, and 410A is 2,080 times more global warming potential than CO2, is that right? So it's something you want to consider carefully. It's also, as Ben I think mentioned, it's a little spendy. It's more like 20,000 per apartment to do this system. Here's a system that doesn't really exist yet, but I've been kind of excited about this for the last year. It's a unit that sits entirely on the inside of the building and just has 2 6-inch ducts that penetrate through the wall. I think they sell them even with the little ducts and the whole thing all as a package, and pretty good efficiency. That I called up the manufacturer. Do they call themselves Innova now, or
they gave themselves a new name? Yeah, Epica or Epic. I don't know.
I called them up to this last week, and they said they expect the testing results from Intertech any day now. They've had that stuff in for some months, and after that it goes to HRI for certification and listing. So it's still at least a few months more out, but these things are pretty reasonably priced, and there's, I think, another competitor that's coming on the market besides Epica, and it just fastens right on the wall there, and you plug it in and you're pretty much done.
And 2 little holes through the wall instead of a giant sleeve, which is some of the systems we're going to look at next. And
right.
It's worth noting, this is very much like 1-to-1. You may end up needing a unit for a bedroom and a unit for the main apartment. Just know that you're stepping into that there's no real ability to deduct or zone these.
Hey guys, wanted to see if we can get a tiny bit of clarification. What it says, when you guys mentioned through the wall, does that mean it is vented to the outdoors?
right.
Yeah, it means the quote unquote outdoor unit that you would have for a split heat pump actually lives in the unit, similar to a package terminal heat pump, which we'll show you next. And instead of having a big old sleeve through the wall, you slide a unit in, it's just got two small ducts that do air exchange. So it pulls air in. Duane actually shows that really well. Pulls air in, takes the heat out of it, pushes that air back out again, and then uses that heat pump to warm the incoming airstream on the inside.
Pretty slick. One thing to say about this condensate is here's something where, you know, we architects are often not known for our helpfulness to our engineers, but if you could be with any of these systems that need condensate to drain someplace, if you could just be thinking at a diagrammatic level really early on, where could we have a real simple vertical run down through the building that would collect these all up and not have to do any squirrely things getting around stuff at the ground floor or whatever, that you'd maybe your engineer will take you out for a beer. I don't know.
I'd buy a beer for that. Yeah.
I have two quick questions, guys, and I'll let you guys keep moving along. One is are these very noisy, or are they quiet pumps, and do they have ceiling mounted options or floor mounted only?
So they are wall mount primarily. They have noise data on their website if you go to the, Innova, but you can also go look at their competitors. They're quieter than a similarly sized package terminal heat pump, which isn't saying a lot, but they're reasonably quiet. And there's a question on, are they going to dot a bunch of vents on the wall? The answer is yes, but they are small little things and can be architecturally hidden really easily. It's way better than a similar PTAC, giant grill thing going on.
You could even, for an alteration project, this would work pretty well, and you might even be able to talk Landmarks board into saying it would be okay to poke two little holes at each unit through a wall. They'll be subtle enough that they might not really impact the overall look of the building. No, one last thing before we move on. This and many of these other heat pumps are requiring that I said below 32. That the auxiliary electric resistance heat is locked out above, or no, it's locked out below 32 degrees. And no, that's right, it's locked out above. And so once you get below freezing, you can start using some electric resistance, but it doesn't just, the compressor doesn't just turn off and turn the thing into a toaster oven. The compressor keeps working down to well below what Seattle design temperatures are, and that's in the code. All right.
I'm going to show you some graphs later on COPs and why it's still a benefit to run that compressor down to pretty low.
Yeah, you think we're starting to get geeky now? Wait. So here's my least favorite of all the options, and the new rules will make it harder for these to run, because as I was just saying about that last one, you need to come up with a system that keeps running on compressor only down to freezing, and then runs as a compressor and electric resistance supplement below freezing, which most of these can't do. There are some, but if you've ever stayed in a budget motel and you had a unit on the wall that sort of roars to life whenever it needs to do some heating or cooling, and then does a little clatter thing at the end, that's your package terminal heat pump. The way they're built is that the contractor just puts in, the general contractor just puts in a sleeve that's 16 inches high and 42 inches long. It's pretty uniform that most manufacturers use. And then this package terminal heat pump just pops into that sleeve. It's very convenient when they want to service it, because they can just yank the thing out and replace another one.
They don't service it, they just throw it away and put a new one in. It's very disposable.
Right. So they're loud. They are just a toaster oven when it gets below 45 or so, for most of them. And the sleeve around the edge, maybe they'll do a good job on the first time they install of kind of sealing things in, but over time, as these things get, they do have to get removed annually to get filters cleaned and like that, and pop back in. That little gap between the unit and the sleeve will be a major air leak.
And you're talking about the exterior air intake filter. It's also worth saying, like, we commission some of these. That's part of our commissioning, and we always run a camera scope around the bottom. It's hardly ever sealed. You can almost always see light down through the bottom of that seal. Don't know why. It should be sitting there on weight, but it's really leaky, sometimes to where you can actually feel cold air leaking in that crack.
So you can see why I'm not enthused about these. One other note about this is that the new code for Seattle, and possibly the next one for Washington State, it's being considered right now, says that for each of these things, you have to give it the same U value as you would an old-fashioned double pane aluminum frame window, because that's about the R value. That's about the insulating value you're getting. It's really poor insulating. So you go to all this effort to make a really great building envelope, and then you put these things in, which have very poor insulation. So we're saying, well, okay, if you are going to use one of these, now you have to balance out elsewhere on your envelope design enough additional insulation to make up for the difference between the insulating value of one of these heat pumps and what would have been an insulated wall. So the difference between 0.5 and 0.05 is basically what it is.
Is there on the previous technology, that package terminal, is the COP any higher or different before the toaster kicks in?
Yes, yeah. It's using a heat pump above 45, but the heat pump is super limited. We'll talk about a little about why later, but it's super limited. So it gets down to 45 and it says, all right, I'm done. I don't work anymore.
And you think of how many hours, what are the hours that we need heating in this climate? And I think the average temperature year round is 47 in Seattle. And so for basically the entire winter, you're at the toaster oven thing, right? Maybe considering this is Seattle, some of our summer mornings too. Okay, there's a couple of other options that are sort of oddballs, and I haven't personally seen them, but people wanted me to make sure that to be complete, we did this. You take one of those PTHPs and stand it on its end and put it in a closet in the corner out at the exterior wall, and you can run it that way. It helps a little bit with the noise, although as you can see from the diagram, there's still a louver open to it, so it's hard to completely control noise in there. It's not especially cheap. The one I was looking at just says, yeah, you need a drain pan. So it's another option, whether, especially in the Seattle market where apartments have gotten so small, I kind of don't expect to see it.
It's a lot of floor space, and I can't tell you why, but most architects put this in the bedroom, that closet. I get why, but that means you've got a thing going on and off that it's pretty noisy. It rumbles on, it rumbles off. I can't imagine it makes occupants super happy. Another thing to say, similar to PTAX, it's got that sleeve through the wall. We had an East Coast project that that the whole building turned into a giant humidity pump, because this thing sucks this closet negative relative to outside and the apartment. So it's actually even worse than a PTAC because it's sucking air in through the sleeve. We had a contractor do that poorly, and it literally condensed and rained in this building over and over. It's It's a terrifying thing. So consider ducting the return so you don't have a giant humidity pump.
A relative of this, but a little better performer, it is a variable refrigerant package. Same closet in the corner at the exterior wall. And by the way, you don't have much exterior wall to work with most modern apartments, and so this takes away some of it. But a little bit more expensive, and I guess it's the same noise problem. Is that right, Ben?
It's a little better. So this has a variable speed compressor. That's the main difference. Only one manufacturer makes it. So it's proprietary and priced that way. But the compressor does a slow ramp up, as does the fan. So it's a little less than the rumble to life and rumble back off. At least it comes up over 20 seconds, right? Which is a little less jarring. And the fan and compressor are noticeably quieter if you've been in two buildings with the same thing.
We're kind of getting used to the fact that a 700 square foot apartment is considered spacious now in Seattle, but a lot of the rest of the country still have much larger apartments and garden style apartments, and maybe there's room for such a thing there. So having a hydronic system through your building is great. You could, as you see there, you could do, you could have heat pump on the roof or elsewhere. Like you see at the bottom of the diagram, you could have the heat pump down in the garage where temperature stays a little more cozy. And then that can feed a radiant floor system, or typical kind of radiator at the window, or fan coil. There's a number of alternatives that you can do with that with that heat. You could do a 2-pipe, which would mean in most cases, you got to switch over seasonally from when you end your heating to when you start your cooling. And you could do a 4-pipe if you have a really generous budget.
It is worth saying that 4-pipe also gives you some neat energy recovery things, but only on big buildings that have more like a central plant style heat recovery chiller thing going on. Heat recovery chillers are a relatively new technology that we should be talking, we'll be talking about lots in the future and lots on the upcoming few slides. But they're basically a chiller that can run backwards as a heat pump and provide heat instead. So think your very normal air-cooled chiller, and then picture that running its refrigeration loop backwards to put heat into the building instead. And that is a heat pump chiller. So in that 2-pipe example, you have to switch, you have to pick. Are you in cooling or are you in heating? Which means, at least through the spring and fall of the year, someone is unhappy all of the time.
Yeah. Oh, also notice the very bottom there. We have seen some units already appearing that are using R32 refrigerant, which is got a third or a quarter of the global warming potential of some of the current refrigerants.
Duane, just because you brought that up on refrigerants, we had a question before for VRF. Is there any other alternative refrigerant outside of R410A?
Ben?
Yeah, that's a technical, I'm not going to jump too far into that hole, but yes, in other countries, however, not yet in the US. And there are some technical reasons why. I'll leave it there.
In Japan, virtually everything is R32. I've noticed that Japan is not bursting into flames, but that is considered, I think the technical term is actually mildly flammable refrigerant, yes. Right?
I like to say it's only lightly flammable. You have to get it up to huge concentrations for it to be flammable. Our codes don't recognize the difference between flammable if you look at it versus huge concentrations to be flammable.
Yeah, I've heard you have to use a blowtorch to get this stuff to burn, but in any case, yep. I think they've completed those. It's legal in R32 is explicitly allowed by Washington state legislation. So, and I've been here talking to manufacturers as we've got ready for these seminars, and everybody is hustling to try to get those to market because they might not care about Washington, but they really care about California.
This is a volume thing, as well, volume of refrigerant as well. So in a packaged unit, most of what we've looked at here are packaged units. Your quantity is small. You don't have to worry that that's a lightly flammable thing because you're below this magic number in the code, the maximum allowable quantity. But if you're VRF, again, you have a huge refrigerant volume. So it's going to be a holdout, or we're going to need our codes to make a change in the next cycle.
But let's
Our
look at
building and fire codes.
Let's look at a solution that Ben invented a couple of minutes ago here.
I didn't invent this. This is combining an oldie goodie with a new water source heat pump. So for, I don't know, from the 70s to the 90s, water source heat pump loops were very common. 2 pipes, and you'd have a boiler and a chiller or a cooling tower, depending on your climate. So you had heat that you could put on the loop and heat you could take off the loop with the chiller or cooling tower. And then the water source heat pumps are packaged. They're a lot like package terminal units or the vertical terminal package units, but instead of an outside air, it just uses water to that boiler or chiller. And in this case, the temperatures it needs are perfect for a water source heat pump. So that same water source heat pump we were just talking about is actually an even better solution if you do, air to water heat pump or a heat pump chiller is an even better thing to do for water source heat pumps. We're saying you still have that compressor noise in your apartment. You still need a closet most of the time, although they can make ceiling mounted vertical or horizontal versions. But particularly for high-rise buildings, this has always been a viable option when you get beyond where you can push for VRF, which is a good many high-rise buildings. So if you're doing a high-rise tower, like the future is here. This is amazing. Your closet doesn't have to be on an external wall. It can sit far into the internal core with just an outside air opening. A lot of flexibility to these.
So in case that went by some of you, the unit on the top that I forgot to label there it is air to water heat pump, and it's heating or cooling the water in that loop depending on the need to keep it in that 50 to 90 range. And all the refrigerant we're talking about is contained in the unit or in the other little units. And then the actual piping lengths, instead of being refrigerant with that leakage problem, this is hydronic, and as long as that stays in that 50 to 90 range, then there's heat for the individual units in the apartments to be pulling heat out or putting heat back into that loop. Did I say that right?
Heating and cooling would be putting heat back into that loop. So every apartment gets its own temperature control. There's no switchover issue. Like my building was in heating, but the one with sun wanted cooling. And there is some free cooling options in some of the air to water heat pumps, free cooling, where it doesn't use the compressor to still provide a cooling effect when the temperatures are right. It's compelling. On a high-rise building, it's extra compelling if you can't do the refrigeration lift. And if we, as you'll see in slides later on, when we really talk about getting rid of R410A, this is going to be one of the solutions out of that.
Yeah, or at least reducing the volume of whatever refrigerant you're using, because your main circulating is going to be water.
Quick question on the water. Where would the water be stored, and how much would it be needed?
It's a closed loop. So you might have a modest storage tank because it helps your chiller run better, but that storage tank will be pressurized as part of the loop. So you would have that air to water heat pump or heat pump chiller, same thing, sitting up on the roof or sitting down in the garage. There's some benefit to putting it into the garage, like Duane said, because you get slightly warmer winter temps. And it would have maybe more like a fat spot in the pipe than a real tank. And then you would have all of that loop volume running around in a closed loop, so it never brings more water in. It's just sitting there circulating. and you use the water source heat pump, either puts heat in or pulls heat out of that loop depending on its need. So there's no more water, and there's not a lot of storage beyond the chiller.
And it's a 2-pipe system, and I presume that those 2 pipes could be cast into the floor slabs. So you've got and note there that simultaneously that unit on the top that's in the direct sun is cooling, and the unit on the bottom that's in the shade is heating, and they're actually in this loop supporting each other.
Yep. Oh yeah, they get to share the heat. The chiller, the rooftop chiller doesn't have to do anything if it gets close to balanced. It's great.
Now, if you ask your engineer and it's not FSI about this system, they will probably give you a funny look, but it's a
Just
possibility.
tell them it's like water source heat pump loops, but without the gas heating. They'll get it.
Okay, so Ben.
Oh yeah, so this is my special note on compressors, and we kind of already alluded to this, but what you're seeing on the page here are the cheap versions. They're single speed compressors, and they have a real limitation on how cold out it can be before they stop working. So Duane talked about 45 for PTAX. You know, some of these go down to 25. If you've got a heat pump in your house, it probably goes down to 20 or 25, and then you use emergency heat, which is just a fancy way of saying electric resistant heating, COP01. Let's go to the next slide. This slide is fancier units with variable speed compressors. Their compressors work a lot lower. I'll show you some graphs in a minute. But that bottom left corner, we got so much interest in that dual duct through the wall unit. That's what it looks like hanging on the wall. Little teeny unit. VRF, and then Friedrich makes the variable speed vertical package heat pump. Next slide.
Hey Ben, if you don't mind me interrupting before the slide, as we spoke with all those systems, is there any specific, when it comes to the air barrier test, is there any specific system that will not make people fail the air barrier test?
You know, so passing the air barrier test, it is now lower in this version of the code, but there is a bandwidth there where you actually have to fix what you can, but you don't have to rip your walls apart. And what I would say is the ones that can help you fail are the ones with the big wall sleeves. All of the other units are going to be very much what we've always done. If you do balanced airflow as is now required instead of a bunch of outside air connections for every single unit, that helps a tremendous amount. If you're just careful about air sealing the remainder of your things, your exhaust fans, your kitchen fans, and dryer exhaust, things like that, you shouldn't have real concerns about passing the envelope, the air barrier, the leakage testing, blower door testing colloquially. Shouldn't be a big deal.
Just don't use mechanical equipment that extends through the wall.
Yep, that's like blowing a big hole in the side of your building. Okay, sorry, back on track. So a regular heat pump would have this thing where your heating requirement, supplemental heat, that thing over there in blue, you can see I put the design temps for Seattle and Spokane. Those are the 99.6 percentile. And so Seattle, you're probably going to need electric resistance. In Spokane, you're definitely going to need it. And these are for the cheap version, single speed compressors. Let's go to the next slide. This is Daikin's version of VRF, VRV. VRF is technically a Mitsubishi term. They trademarked it. But you can see for their regular system, Seattle is fine. You have full heating capacity down to Seattle design temps. You never need electric resistance. And if you do their fancier system, their better system, you can get down to near full capacity even in Spokane with their couple degree, nearly zero design temp. So this whole heat pumps can't make it in cold heating doesn't actually hold water, particularly if you're doing the better compressors. I kind of agree if you're going to go out there and put a bunch of PTAX through your wall. Important note, you can also see the COPs are still quite good. So at a COP above 2 in Spokane or Seattle, you're still twice as good as electric resistance heating at those temperatures. So all in all, you're energy ahead for that heat pump.
This would not have been true 5 years ago, is that right?
It would not have been as good looking. The systems of 5 and particularly further back years ago, even with the variable speed compressors, you started to see a capacity drop certainly in Spokane, but even in Seattle, you might lose the top 10% on the coldest day of the year. Yeah, but VRF and has really brought that inverter-driven compressors, variable speed compressors. Also a note on the cost, because one of the things we hear a lot is, you took away my cheap heating with gas, and it's a yes and. So because the heat pump is 3.5 or 4 times as efficient as regular gas heating because of its COP, even at its design temperature, which we don't run every day at design temp, but even as a design temp, it's about at parity with gas furnaces. And it's certainly, it's 2.5 or 3 times better depending on the equipment for electric resistance. And oil, costs more. We don't see a lot of oil nowadays anyways, oil source systems, fuel oil. But on a cost basis, we're kind of at parity. That argument doesn't much hold water either.
Just wanted to mention that in case you've forgotten that in Seattle, multifamily buildings are required to do a TSPR calculation, total system performance ratio, which is just making sure that your carbon emissions are in line with your loads from your whole annual use of your HVAC system. But I just put in this slide to kind of cue up Ben to talk about carbon.
Yeah, so TSPR takes your carbon emissions as the denominator. It's also worth saying the PNNL tool for the designers in the room, it's not a big scary thing. It's a lot like running eQuest, and it's a big block model. You're not building super detailed models. So you should go poke at the tool if you haven't yet. It's actually quite straightforward, and you can usually complete these in even on a big complex building. You might need 6 or 8 hours to get it done. CO2. So this is the nitty gritty, the behind the scenes, like this is why these things exist in the code. Why limit gas and electric resistance heating and water heating? So this is straight off of the power profiler from EPA. This is just our power grid. You can see it on the bottom left there in blue. So I have people say, yeah, but I'm Seattle City Light. My power is 100%, green sources, and I don't generate any carbon. And it's true. Seattle City Light is buying 100%, renewable power, and we are also part of a bigger grid. There's no real distinction between an electron you use in Washington and an electron you use in another one of the states on our grid. So it still matters. Let's go next slide. We have a couple Washington bills coming up. Uh-oh. There we go. We have a couple Washington bills establishing carbon neutrality in our power grid by 2030 and carbon free by 2045. So like any good engineer, let's go next slide. I made a graph because engineers love graphs. So the story this tells is we're here today, and we've got electricity from the grid, that yellow line that goes down over time, and that's just tracking that carbon neutral to zero carbon line. We also have the orange line and gray lines. Those are if you choose to put in a gas boiler today, and the orange line is higher efficiency boilers, the gray line is regular efficiency. They detune over their life, and then you replace them out at 25 years. And so you're always going to generate gas for as long as you maintain that system as gas. And then, of course, heat pumps are 3 times more efficient than electric resistance. So that's that blue line down at the bottom that slopes down over time. So if we do electric today, and particularly if we do heat pumps, we are going to be heading for a carbon zero line in a near-term future. It's pretty exciting.
And I would add that even even if we can persuade ourselves that we already have a carbon neutral electric source, we need to the extent that we can reduce our new building and remodeled buildings electrical use, we have that clean electricity available as we switch over our whole transportation fleet and the existing buildings and homes that are currently using fossil fuels for heating. So every kilowatt hour we can save is going to be put to good use over the next decade. Well, just wanted to get back to that rule that we have in the code that says, yeah, you gotta use electric resistance or fossil fuel. You gotta not use electric resistance or fossil fuel. So you're gonna use some kind of heat pump, and for the common areas, you'll need to go and do something, a larger scale heat pump system. But as we mentioned, for the dwelling units, you can do that electric resistance if you so choose. So we have, it gets complicated. There are lots of allowances for small loads and for very cold weather. Just keep that in mind.
So that number 3 passive house rule, I just want to put this in reference. The last passive house we did, the envelope was twice as good as code, and the windows were 3 times as good as code minimum. So it's a very hard barrier. So great, no electric resistance or gas heat. That slide should look pretty darn familiar to you. That's the things we were talking about. I actually added the water source heat pump is that little galvanized looking box on the lower right. You can use these systems. They're all heat pump based. Great, pretty normal. And then let's go to the next slide. You can also use hydronic systems. We already talked about it. On the left there is that heat pump chiller or air to water heat pump, depending on, literally it's the same thing. We use different terminology depending on the firm and the exact manufacturer. On the right is a centrifugal chiller plant set up to do heat exchange for a 4-pipe system, but it's the same idea. It's moving heat around and rejecting heat out when appropriate, pulling heat in when appropriate.
Now, wait a second, Ben. I've never understood this nomenclature. You got this unit on the left is intended for heating, but you're calling it a heat pump chiller, right?
Sure. So just like we were saying, hey, if we're going to use heat pumps for heating, you get that benefit of free cooling. Well, a heat pump chiller, you can run it either direction. It can be heating, and it is much of the year in Seattle, but it will cool just as easily. I make a mention of this, although it doesn't make a lot of sense in most of Seattle. There's also ground source heat pumps or ground coupled. People colloquially call them geothermal heat pumps, doing heat exchange with the ground. And that is also viable. That is all heat pump based.
So when you're in a mode where you're just heating, then this chiller is just going to have to dump that chilled air, waste it out to the outside. Is that right?
It usually does. So there's some fancy things we can do, and we have things like data servers where we actually run 2 pipes into a chiller, and we cool one side and we heat the other side, and it's great. It's so efficient. However, most buildings don't have some huge data center hanging out, giving them all the free heat they want. So yeah, usually just like a heat pump, we're pulling in air from outside and we're rejecting colder air back out to pull the heat out of it to push it into the building. So that is a reality. And then of course that flips in the summer. You pull in air and you push it out hotter because you rejected heat to it. So. All right, this is my favorite slide because it's all numbers all the time. C406, so it's a whole section in the code. It's I like to call it the choose your own adventure path. You need to get points, 6 for Washington, 8 for Seattle, and there's a wide variety of ways to do it depending on what occupancy you are. So we thought we would highlight the ones that we think are really great options and the ones Those are dark green, you know, because this is a presentation on green technology. And the light green is maybe not as cost effective. And then if it's not highlighted at all, it's usually not cost effective. That isn't to say it's not cost effective on your particular projects. So great, we're talking about multifamily here, and the best ones of all, by large, reduced lighting power is nice, but you get 1 point of the 6 or 8 you need. It's the service water heating. That's where we live here. So if we go to the next slide, we actually bring those out because there's some important caveats to know on those. Service water heating, there, boiler, can't do that anymore. So we're looking at heat pump chillers, same idea, only you only run them in heating mode. So heat pump water heaters, same thing as heat pump chillers, you just never use the chilling side. So you get to save a couple of valves in that equipment. Next slide.
And just promoting ourselves, 2 weeks from now, we'll have a whole session on heat pump water heating.
With a different engineer, which is gonna be awesome.
Yeah.
You can watch somebody else stare at their feet. Can't help engineer jokes. Important notes. You, for the Seattle code, have to do heat pump, like this is also in the code, so you, after January 2022, you will no longer get to take credit for a thing you had to do anyways. But up until 2022, free points, woohoo! It's like an all-you-can-eat buffet. And that was 7 points and 8 points, and it'll be 5 after. So it's a thing. Sorry, 8 is a thing you had to do anyways, for which you'll get points. 9 is an above and beyond. Here, I gave myself notes on this, if you want to know the specifics. So for 8, it's a COP greater than 3 and waste heat recovery or solar water heating. For 9, it's a COP greater than 3 and global warming potential less than 675, which is a way of saying, fancy way of saying R32 or CO2 or something similar, these new wave of refrigerants that are doing better. So heat pumps and a refrigerant requirement. All right.
Okay, just to get into alterations for a minute here. In general, stuff that you put into your building and met code back in 1947 or whatever could just stay the way it is. Our boiler inspectors say that they've got some boilers they check annually that are 85 years old now. You can repair stuff, you can service it, but if it's new, if you're taking out the old one finally, dragging all the asbestos with it, putting in a new one, it's got to meet code. And in Seattle, we have this concept that everyone covers their ears and runs away screaming when they hear substantial alteration. But that means that we've considered that the building is being overhauled to such an extent that we're considering it pretty much an entirely new building. And then it's not just energy, seismic, life safety, and this is the way over time we start upgrading our building stock as buildings get to that point in their life cycle where they get a major renovation. If we're replacing heating stuff, anything new you do has to comply with the whole HVAC system. If it's a central system, it has to be a heat pump. Now, if you've got one of those many Seattle office towers with VAV reheat, you know, the electric reheat on, and you're replacing individual fan coil units around the building, and it's not a substantial alteration project, then this doesn't kick in. We also clarified that if there's an emergency, so you've got a central piece of equipment that is failing and it's January 14th and people are starting to call up and say, what's happening, we're freezing, you can do a one-for-one replacement just with the existing type of equipment. But that doesn't apply to any kind of multiple pieces of equipment or planned replacements. So,
Duane, a question on that I I've been wondering. So if I'm a developer or an owner, if I'm an owner who wants to jump through the loopholes and I have a failed boiler, can I just wait till they fail? And great, one failed this year. I'm ready. I got one sitting on the shelf, and then do the same thing again next year when the next one fails. If I know they're all failing, is this a loophole?
It is, yeah. And yet, unless somebody comes up with a better idea, it's a necessary loophole. I don't know what do you think, Ben, is if I were to call you up today and say, emergency, I need you to replace my gas-fired boiler system with an air-to-water heat pump system, go. How long would it take before that system was online?
At a very minimum, it's 6 to 8 weeks to equipment. However, for large boilers, it might be 6 to 8 weeks for equipment. It's a thing that if you're going to just wait for failure, you're really playing risky with your building and occupant comfort.
Right. I was just thinking that when I made this rule that you've got to consider that your that there's design time, and when you put in a heat pump system to replace your old gas boiler, it'll take more physical space. You'll have to have an outside air source. You'll have to make new connections. Anyway, and so my thought was, that's not just something that you can sketch out in a couple of minutes and call up and order the parts for, right?
Correct. Yes.
It's a design project.
Yes. Yes, it is. And a boiler might just be a drop-in replacement if you can get your hands on one.
Right. Of course, getting your hands on anything right now is a trick.
Oh, I forgot the wiener dog.
The stick situation. This is engineer humor.
Yeah, this is our marketing director's humor, to tell the truth. So substantial alterations, Duane already said this. This is a thing that, it's a negotiation, and we're always in the position of negotiating our way out of substantial alterations. But once you go into a substantial alteration, great, you're doing heat pumps. It's worth saying you were doing TSPR anyways. If you were replacing mechanical equipment, you might have been doing heat pumps anyways if you were replacing mechanical equipment. But if you're replacing more than a system, you got to go have that pre-submittal conference and talk it out to know if you're a substantial alteration and therefore need to do, within 10% of UA or 15% of building performance factor of your whole envelope. It can be a big deal. It can be project altering or possibly project stopping if you don't get on this early in design.
Yeah, this is one of the main reasons that my popularity ratings are all down in the low single digits usually. Okay, a note about refrigerants. Just this year, legislature said, okay, starting with heat pumps made in 2025 or for VRF systems in 2026, you're gonna have to come up with refrigerants that have a global warming potential below 750, which counts out the ones we typically use today. So word to the wise, start planning now and get in touch with all your product reps and start finding out who's got R32 or other advanced refrigerants on the market, and go for those when you got them. So just remember that for the 2025 date, that's not the permit application date. That's when the equipment was manufactured, and I'm guessing that most major equipment is manufactured within a few months of the time that it's shipped. Ben, does that sound about right?
Yeah, we've been to the train factory, and there aren't acres and acres of air handlers sitting out there. There's a lot, but it's not for the volume they're making. They're getting on trains and leaving.
So so anyway, that's something to start looking for is when you can make the shift with your projects to better refrigerants. That's our part of the thing. And before we go into City Light's next presentation, Armando, do you have other questions for us?
No, you guys have been doing a great job at it, so thank you. I do encourage, if anyone has any questions, comments, please just put them again, put them in chat as you have been doing. It's been great discussion and questions and answers. But no, you guys have done great explaining the systems and code and alterations. So we can move on. I believe we're gonna be looking at here is a collaboration from Seattle City Light, but Energy Solutions distributor on HVAC systems, and they're going to be discussing the midstream program. So I'm going to tee up Sarah Brown and Howard Merson. If you guys can come on our webcams and get us out in here. Thank you.
Thank you. Well, just to start with introductions, my name is Sarah Braun. I am the program manager from Energy Solutions, working closely with Emma, who you met earlier, on rebate programs for some of the equipment that Ben and Duane just covered. City Light offers quite a few incentives for high efficiency equipment, so we're going to cover those with you today. Howard, would you like to introduce yourself?
Sure, thanks, Sarah. Yes, I'm Howard Merson. I'm a senior manager working on trade ally strategy and management. Work very closely with Sarah, and I'm overall our Seattle City Light midstream team. So look forward to having a discussion with you today about the midstream programs. And perhaps if you have some questions, we'll be able to answer that today. So thank you very much.
Thanks. Next slide, please. Great. So Seattle City Light offers an HVAC and heat pump water heating rebate program jointly with Puget Sound Energy throughout the qualifying program territory you can see on the right side of this slide. We're going to be focusing on Seattle specifically today, but just know this is a regional program, and a lot of what we're saying applies outside of Seattle city limits. This program is a rebate program offering contractor incentives through enrolled distributors. So you'll get an incentive for high efficiency equipment from your distributor, and you're encouraged but not required to pass some of those incentives through to customers. If you find a better use for the incentive as training or marketing materials, that's all totally fine as well. The rebate program offering covers heat pumps under 5.4 tons, hybrid heat pump water heaters, and ECM circulator pumps. And since it is our HVAC focused presentation, you'll have to come to one of the future series offerings to learn a little more about some of the water heating options. One other thing I'll note is this program does cover residential and commercial installations. A lot of the multifamily buildings we've been talking about will be eligible. And really the overall program goal is to promote the stocking and upselling of high efficiency equipment in the Seattle region and beyond. City Light's customers get access to high efficiency equipment through program offerings like this one. We just want to support overall energy use reductions and carbon emission reductions through this optimal HVAC design. Next slide, please.
Yeah, but when you said residential, that does not include single family, is that right?
It does include single family.
Oh, it does. Okay.
Yep. Yeah, so single family, multifamily, and commercial buildings. Great. So as far as accessing the program, it's really simple to participate. You just need to check if the distributor that you're purchasing equipment from is enrolled in the program, and we'll get to how to do that in a moment. You would purchase equipment for this qualifying installation in Seattle territory or one of the territories shown on the previous slide through your distributor. We have qualifying equipment information to cover later on as well. You just share some information with your distributor, receive a rebate, and that's it. The distributor completes the paperwork that will include some of the information on the right-hand side of this slide. That will just include some really simple information about the project, installation address, the type of building, again, whether that's single family, multifamily, or some of our common commercial buildings in Seattle, like offices. And then you might also provide the product type and estimated installation date. Next slide, please. So we have a variety of distributor partners engaged in this midstream program, and any of these folks will be able to connect you with rebates for the equipment we mentioned before. A lot of our distributor partners are fairly enthusiastic about the program. You can see some quotes on this slide. Gensco, one of our large Mitsubishi mini and multi-split distributors, has mentioned that this is one of the most successful rebate programs that PSC and City Light have ever offered. AirReps is a Daikin mini and multi-split distributor. And again, they're very on board with the goals of the program, stocking and selling high efficiency equipment. So if you have contacts with any of these distributors, you can get connected with them to access some of the rebates that we'll talk about on future slides. Next slide, please.
Hey, Sarah, I have a quick question on, and maybe it gets addressed here in this process slide, but when it comes to the incentive, who contacts the utility and when? And if that's coming up in this slide, then yeah, we'll let that rock.
Great timing for that question. Yeah, it'll be on the next slide. So essentially, the goal for this program is for most contractors really to only interact with the distributor and the customer. Once you have a customer engaged with it, installing some of this high efficiency equipment and you purchase the equipment, that information is provided to the distributor. That distributor will provide a rebate back to you. You'll get that rebate and focus really on the customer from there. You can offer a discount, you'll receive the rebate and be able to offer competitive pricing if desired. You'll move on with the equipment installation, and if you keep some of the rebate reinvested into what we hope to be more high efficiency sales. As far as where the interaction with City Light plays in, the distributor actually works with us at Energy Solutions. They'll submit information about the installations that are coming through the program, and City Light will issue the distributor rebate, which Energy Solutions will help bring back to the distributor. But really, as soon as you have a qualifying installation and then have worked with the distributor to obtain the rebate, you're done and back to focusing on the customer. Next slide, please. And I'll turn it over to Howard to talk about some of the eligible installations in this program.
Thanks, Sarah. Yeah, so the technologies that we're supporting that we're going to discuss today are HVAC, water heating, and fans and pumps. And so let's just quickly look at water heating. And we're working with the following manufacturers and the distributor network, but it's when we work with the manufacturers, we're also working with the rep agency. So for example, in water heating, A.O. Smith, their manufacturer rep agency, Hollopop Brothers and Associates, and then that includes A.O. Smith's other brands that A.O. Smith manufactures, such as American and State, but they have various brands underneath the A.O. Smith banner. Bradford White and their manufacturer rep agency, Synergy Sales, and then Ream, which also includes Rude, and Ream's manufacturer rep agency, Stone Drew, Ash, and Jones. So the incentives, for, let's say, for example, with heat pump water heaters are $500 per unit. And we have an overview of all of our incentives as we go through this and on our website. But next slide. And Sarah, back to you.
Yeah, so as Howard mentioned, we do have specific incentives broken out by types of equipment. So we just wanted to share a couple of the qualifying criteria with you today, really focusing on the heat pumps in the upper left-hand corner of this slide, but also just letting you know there are, again, incentives for hybrid heat pump water heaters and ECM circulator pumps available. So focusing specifically on the heat pump incentives, we have really two types that we distinguish in this program. One is the mini or multi-split heat pump, and then the other type is the traditional heat pump. Based on the efficiencies of each of these heat pumps, the rebate will vary slightly. So you'll see our more efficient heat pumps get higher rebates across the board, and we're really looking at $400 to $600 rebates for our mini and multi-split heat pumps, and then $300 to $500 rebates for our traditional heat pumps. Next slide, please.
Great, thanks, Sarah. So I'm going to quickly go through just with the multifamily large commercial installations. City Light and Puget Sound Energy, we're working across the supply chain, as we mentioned earlier, and that's to support not only the residential needs that we had a question about, but certainly the needs of commercial and industrial customers, the C&I space. It would be best if you work with your respective distributors to determine the incentive opportunities that are available for your projects and install opportunities. The distributor can also work with you as far as ensuring that they have availability of the products that we're supporting in the program. We're constantly working with the supply chain, and I provided the examples earlier of manufacturers and reps to ensure that we do have the supported technologies on shelves at your distributors. Some of the technologies that you should be working with your distributors, and this is in the C&I space, we had a discussion earlier about some of the technical components, but variable refrigerant flow, so VRFs. I didn't realize that was a Mitsubishi trademark name until today, so that was interesting. Water source heat pumps, split and packaged heat pumps and air conditioners, and fans and pumps that are rated. And we have a new system that's been in place now in the industry, but the fan energy index, which we refer to as FEI, and the pump energy index, which is PEI. Next slide. So we've covered a lot, Sarah and I, over this section in a short amount of time, and it's been a ton of materials, but you should know that you can reach out at any point to Energy Solutions, Seattle City Light, your participating distributors and manufacturer rep agencies for information about the programs and additional information. On this particular slide, we've noted an email address that you can access at any point for rapid responses and answers. We have a telephone hotline, a website, and then all this is so you can have whatever information you need to source the products, take it certainly full advantage of the incentives that are being offered in the Seattle City Light and Pacific Northwest Territory. But areas such as participating distributors, incentive amounts, equipment eligibility, if you need some sales and marketing support materials, or if you have specific inventory requests as far as the supported equipment, any type of training needs, these areas that you can resource as far as information, those are the type of questions that you can ask. And we know that moving your customer base to high efficiency equipment is great for the area, for Pacific Northwest, and it's actually a really good influx to your business models. So really appreciate your time today, and have a great rest of your day.
Thank you very much, Sarah and Howard. Duane, you mind moving us on to the next slide?
We're there.
Oh, guess I'm not seeing it. I wanted to stop here and just mention, hey, we have a good amount of panelists and experts on both program incentive rebates, technology, engineers, code officials. If there are any questions, specifically if you're looking at projects, it'd be great for you guys to drop us a line or ask us now. I'll just encouraging more questions. Wanted to also note that we have a couple of more deliveries on heat pump technology on commercial and institutional buildings next Tuesday, June 15th, and on heat pump water heating on June 22nd, all starting at 10 a.m. Julie, do you have a few words to share with us? I see you out here.
I do, yeah. So
Please.
we just talked through some of our midstream HVAC incentives, and I'm Julie Banerjee. I also work at Seattle City Light in our new construction programming, multifamily, and commercial and industrial space. And so Sarah and Howard talked through how we engage with distributors directly to get you benefits and access and incentives for some of these equipment. One of the questions, it was like, well, traditionally we're used to working directly, right? Customers purchase qualifying energy efficiency equipment and then apply to the utility for a rebate. And I'm here to talk and say that some of those offerings are actually still available. So we have offerings at that midstream level, and then we also have those more traditional offerings. And what we've been doing in my program team and at the utility is to work with Duane and Ben, people like Ben, to really look at, okay, these are all the ways that we can achieve and hopefully exceed these energy code requirements and help you achieve your energy efficiency goals. And that's one of the core reasons we have a multifamily new construction program, is to help you exceed the energy code and achieve those lasting benefits. But we've been asking ourselves, what does this look like, right? With the increase in code and maybe changing goals for developers and design community around future focus. We talked about cooling. So we're reworking these direct program offerings in order to support key technologies that customers have said, hey, we need support for this to be successful in achieving our goals, and also shifting to a whole building incentive approach. So instead of looking directly at the HVAC equipment, we look at the building as a whole and say, what is happening here to have energy efficiency savings versus a measure basis. And that's one of the ways we're pivoting our programs to support. We have this midstream support, and then there's a level of creativity to achieve energy savings. So you can actually leverage a lot of the different systems that we talked about today and have energy efficiency incentive payments received to you. So I'm also available for any questions on the downstream incentives, and we'll send more information out on that.
So yeah, thanks a lot, Julie, and thank you for encouraging more engagement on our programs and how Sales City Light can help you meet your project needs and get a payout for it. Not seeing additional questions, but always wanted to be available for you guys. You'll see Duane and my contact info if there's any questions or comments, or you wanted to have us point you in the right direction. Again, a recording of this presentation as well as a slide PDF is going to be available on the lightingdesignlab.com website. We also have a YouTube channel on Lighting Design Lab. We're going to have the recording up there shortly after this presentation. Next slide, please. So barring any other last comments or questions, I think we can call it for today. We've had a great time going through a lot of material. So again, if you any last thoughts or comments, please drop us a line. But thank you everybody for joining us. Thank you to all of our panelists and presenters and speakers. It's been great learning from you guys. Have a great rest of your day. Thank you.
Bye.